let's see coin change problem again. So in the previous video I showed you Approach2, and that's not a very efficient way, but that gives the solution, but it takes more time. And today I'm going to solve this problem with Approach2. So Approach2 is dynamic programming, and here we use the recursion and dynamic programming. Let's understand this problem once again, this coin change problem. So there are 3 coins given here, and you can use any number of coins to make 11. So if I use the 1 11 times, then it is 11 and I need the coin 11. If I use the 5 2 times, 5 5 10, and then 1 coin 1, then that's also 11. So in this case, if I use the 5 5 and 1, I just need 3 coins, and if I use the 1, then I need many coins. I need 11 coins, and I need to find out the minimum number of coins to make it 11. So that's the problem, and we need a solution. So one of this solution was in my previous video. You can go and watch and get some ideas over there, and today we'll see another approach. So for this code I'm going to comment for now, and I will start my other codes here. Okay, so another approach for this is dynamic programming, and we'll see how I'm calling this. This is the recursion call. You do not have to go through all these things, but just try to get some ideas from here, and you can draw this diagram by your own, at least first time, and you'll get a lot of ideas. But the problem is here, this is the example here, 3 5 2, and this 3 5 2 are different coins, and I want to make it 12. So when I make it 12, then I need this all 3 coins, the combination of all 3, like you see the 3 here. So for the 12, 3 different approaches I just need to make 12. So what I do, I go the bottom and I just calculate for that and bottom solutions, and that solution, and then eventually I come to this top solution. So what I do for 12, I need like if I subtract 3 from the 12, which is 9, and 5 from 12 7, and the 2 from 12 10. So 3 different directions I'm going, like that is 3 different recursion is happening here. So what I need what are the number of coins I need to make 9. So what are the minimum number of coins to make 9? What is the minimum number of coins to make 7? What is the minimum number of coins to make 10? And in the same way again, from the 9 I will calculate the new target. So 9 minus 3 is 6, 9 minus 5 is 4, 9 minus 2 is 7. And in this case also, here also I need what are the minimum of number of coins I need to make 6, minimum number of coins to make 4, minimum number of coins to make 7. And in this way I will go the bottom here, and in this way I will collect all these results here, and from here, like let's say for the 12, I need the minimum of number of coins is 4 in this route, 4 in this route, and 3 in this route. And so whatever the minimum, that's a 3, so that will be my answer. So that's like here 5 5 10 and 2 12. So that will be the answer. We'll come back to this screen. First we'll see the code, and from the I'm just going to use this technique, and then we'll come back again, and that makes sense a lot. So for this coin change, let me call this function here, like just I need one for loop here itself, like for loop, and from the for I get the coin one by one. So that's let's say C is a coin and range coins. In this way, we're getting the coin one by one here, and I'm calculating some answer. I'm just saying that my answer is something like math max number, max int. So let me create one helper function and we'll write this thing here. So for now, call this whole function here. It's going to return the value, and whatever the value it returns, I'm going to return from here. So this is Approach2. Call the function coin change and we'll pass the coins. So that's the coins we pass, and then we'll pass the amount, and we'll modify the code accordingly. And here I'll say the answer. So first I will give the answer is something very max number. That's a math.max int. And then I will iterate through each coin. So I'll get the each coin, range coins, and this is the number, the fee, like each coin we get. So now I check my amount. This is my amount. So if whole amount minus coins and the V is a coin, so let me make it C. So amount minus C is greater than equal to 0. So if the coin is greater than equal to 0 amount, and if I subtract this coin, then new amount will be calculated, and if it is true, then only we'll call the function. And we can add the base condition. So when we subtract this coin from this amount, the sometime amount will be 0. So we can check that condition. If amount is equal to 0, then return 0. Otherwise we'll come here and we'll call this function coin change, and we'll keep calling this function, and this time pass the coins, but the amount will be different. So amount minus C, that's the new amount we're passing here, and that's a like sub answer, and we'll get sub answer. And if the sub answer is not a max, because we have put in a max, so there is a chance it will not go inside and that number will be still max. We'll see how it happens. But if it is a max, then if we can check, like if answer, or I can say sub answer not equal to max, math dot max int. If it is not, then our sub answer, we just add 1 to the sub answer. Sub answer plus 1, and then if logic is done here, and then here you can put answer is equal to mean of answer and sub answer, and we'll get the answer here. And we are going to use the dynamic programming, which is going to use the memoization. We want to store that value, but first run this and then we'll see that. So and then return answer, and then we'll try to understand this code also. Again, line 25. So we are going to return, so that's what it's asking. coin change redeclared in this block, so it's a coin change helper 2. Let's name this coin change helper. Just copy this thing and call this function again here, run it. 41 answer is called, so answer we defined within the main, so here itself within the if we need to calculate this. Run this now. 2 3, so it is 2 3. Okay, so we need to handle this thing here also. So this is our result, and if result equal to math dot max int, then return -1, else return result. It's accepted, but if I submit again, it's going to reject because it's going to take more time, and here we need to use the memoization. So I have also explained about the memoization and dynamic programming in the first 25 videos over there. You get the idea from there, but I will also explain it. But let me add this result. In order to add this result, I just need a map here, so I'll just create the map, make map of int, and I will pass map this function. And when I get the final result answer, I can store that in a map. So our some m answer, and the answer for the particular amount, so I will add the amount, and then I will store the answer here. And then in this case, if I come to this place, before calling this coin change helper 2, I see if the answer is already there. If it is answer, if I find the answer, I will return the answer. Otherwise, I will call this recursively again. If I find the answer, then I will return from here itself, and that's called memoization and dynamic programming. So I'll check if okay, a for answer, and this okay, and checking in m, and that's amount. If it exists, that's okay, then return a itself. So let's see, 48 not enough arguments, 48. Run it again. There's a 45. Coin change helper 2. Okay, here we need to pass the map. Run it, except this should work. Yeah, it's working now. Let's like if you have the clear idea about like what is happening here, that's fine. You can skip the video here itself. But if you are not clear, then we'll try to understand this, like what's happening here. So first of all, we call this function. Let's try to understand with this example. So let's put it side by side. Okay, so let me now let's try to understand. So we call this function coin change helper 2 for 12. Let's say for the 12 we are passing the 12, and the coin is the 352. So 352 are 3 coins and our target is 12. We want to make the 12 here. So first of all, we make the answer. So answer is very big number, and this is our base conditions. And here when we got the 12, when we got the coins 352, we are iterating this 3 times. So we'll call 3 7, we'll call the function for the 3 7 and also 3 7 and 10. So for the new 3 7 10, we call the 3 functions. So when you call the 3 functions, it will return something, and after that we need to have some logic here. So that's what, if you see here, this function we call the 9, because we got the coin and we are checking okay, amount minus c, like 12 minus 3 is a 9. 9 is greater than 0. Yes, so we'll see condition is true, and it's going to call another function. So and this function returns something, and then we do some logic. So here this function returns 3 and we do some logic. The 3 plus 1 is this logic, and here this function returns something. We'll understand that. Again, we call for the f7 returns some value, and then we do this logic. So okay, we'll see that. So this function called coin change helper 2, this is in the for loop, so it called the 3 times, and for the 3 times it called this function. Again for 9 it called the 3 times, again will come 6. It says remaining, but it's all the remaining things, that function will be called again, but this is going deeper and deeper. For the 6 we call the 3 times. For the 6 there are 3 coins, so 6 minus 3 is 3, 6 minus 5 is 1, 6 minus 2 is 4. So we are calling this function again 3 times. We'll come back here. For f3 we are calling this function 3 times again, and when we call the f0, so f0 will return 0, because for this is the base condition, return 0. So this function is returning 0 here. So this function call f0 and f0 return 0. So for f3 call the f0, and there also some remaining stuff here. So f3 call this for the 0 and the remaining stuff here. The remaining stuff we'll check here. So whatever the value this is going to return, I'm just going to add 1 over there. So this function will return 1 for like this function call. When we call this, then it will put this 1 in an answer, and then we are going to return that answer, and we are also storing that answer somewhere. For the f0 we already run this and we got the answer. So this is we cannot say the answer 1 now, but this will return 1. So for this call, but in order to decide what it should return, we need to find out this 3 call, what is the minimum number, and that's the minimum number is final result of f3. So this call f3 and call f minus 2 also. For f minus 2 it will not go to this for loop, and it will directly come to the answer, and the answer is the very max number here. So if it is the max number, then it's going to return very max number. For f1 also, for f1 it's going to return again max number for the 1, because for the 1 there is no coin also for that. So this is going to return max. So for the f3 result we'll check which is the minimum. So the minimum will be 1. So for f3 result is 1. So in the similar way, for the f1 max, that's already we have already put that result in a map. So from that map we are getting that value here. So for the 2, in the similar way we calculated the 2 for the 2 value, and then in other places for the 2 we are not calling the recursion. Like if you see this place, we are not calling this recursion again, because we are getting that value from map here itself, and that's the dynamic programming. It's a memoization. So in each step, like if you analyze here, if you each step you will see the F3. For the F3, what are the coins, how many coins we need to make this target. Then for the 3, I just need 1 coin, so result is 1. For the 6, how many coins we need to make 6? So 2. So 3 3 6, 2 coins. So at any moment of time you can see, for the 9, how many coins we need? The 3 coins. The 3 coins to make 9. So in this way, we from the bottom up we are calculating all this result, and finally for the F12 we get the 3 result. Like to calculate F12, how many coins we need. So we find the minimum of all these 3. So this is the 3 coins, here 3 coins, and here 2. So minimum of 3 3 2 is 2. But here it's a 2 plus 1 3. So 3 plus 1 4 here, and 4, and the 2 plus 1 3. So the final result is 3. So to make the 12, we just need the 3 coins. So that's the logic we are doing. So this is the function call, internal function call, and then this portion is checking that, like adding plus 1 over there, and then we find the answer. So this is a very efficient way to solve this problem. But thing is, like, if you try to memorize this thing, this is not the good way. But what we do, what I have drawn here, if you start with a very small number, maybe with a 2 number, and draw this kind of this flow, and then just try by yourself once, and then you have the very clear idea about what's happening here. And that's also helpful in other problem also. But for the first time, definitely it's going to be hard. If you just try to remember, then it will be very difficult. You will forget after some time. But if you go through this diagram, then it will be always in your brain. So that's all for now. Thank you. We'll see. Okay, one more thing. We'll see another approach, like dynamic DP array approach, to solve this same problem in the next video. So that's all for now. Thank you.